6.2, solving with similarity. What the heck is similarity? Well, I'm about to tell you. For similarity to happen between two figures, basically, here's what we need to know. Similarity is defined by the fact that all corresponding angles between two figures are congruent and all corresponding side lengths are proportional. Here's an example. And let's go a nice 3, 4, 5. And a 6, 8, 10. Okay, these two triangles are similar because I can see that I have two right angles. These also mean that these angles are congruent. That also means our third angle has to be congruent. So all corresponding angles, meaning angles in the same spot between the two figures, are congruent. And also, all corresponding side lengths are proportional, meaning that here's a corresponding side length here, 3 and 6. So like 3 over 6 is the same as 4 over 8, which is the same as 5 over 10. Because all of those ratios come out to be the same thing, then that's what we mean by the side lengths are proportional. So the big idea here with similarity I'm going to rewrite this actually in a different way that makes it a little bit easier. Similarity happens when a shape is multiplied by a scale factor, aka a dilation, which is what we talked about yesterday. So with that, and to get this a little bit more specific, let's say we have some notation here. I'm going to go A, B, C, D, E, F. Okay, so I'm going to say triangle ABC is similar to, which is like a little squiggle, tilde, I believe is what it's called, to triangle DEF. This is what we call a similarity statement. And this similarity statement tells you which angles correspond to each other. So I know angle A lines up with angle D. I know angle B lines up with angle E, and I know angle C lines up with angle F because they're in the same order. And with that, it also tells me side lengths. So side AB corresponds with side DE, which we saw between the 3 and the 6. Or I could have side BC corresponds with side EF, which is the 4 and the 8, or I have side AC corresponding with side DF, which would be the hypotenuse of those two triangles. Oops, going back. All right, so that's our similarity statement and how we can read one. And so with that, let's say triangle ABC is similar to triangle DEF. I'm actually going to define this just one more time. So if triangle ABC is similar to triangle DEF, then setting up these proportions, like we said, AB corresponds with DE, side BC corresponds with side EF, and side AC corresponds with side DF. And that's going to be our big structure of similarity that we're going to look at to solve for missing side lengths. So, for example, the two figures are similar. Solve for the missing length. So let's say we'll just do a rectangle. And we'll do a rectangle facing this way now. Ooh. Right, and let's say we have 4, 11, and then I have, let's say, 26 and question mark. All right, well, what we can do is I can line up my corresponding side lengths. And so the way I can tell which ones are corresponding is because I have my shorter side of my rectangle over here has to be my shorter side of the rectangle over here. So I can say that is 4 over x. And because these are similar, I know that that has to equal the longer side and the longer side. So that has to be 11 over 26. And the way we write the proportions, it just has to be like, notice I went from the left triangle on top to then the right triangle on the bottom. And I was consistent with that in both sides of my proportion. We call this a proportion. Do you guys remember how to solve this? We're trying to get x by itself. And if so help me, if you call it the fish, stop it, rewind, and call it cross multiplication. Because that is what it is called. Because this is math, not fishing. Meaning, because I have two fractions that equal each other, I can take both sides, multiply by x, and then I can take both sides, multiply by 26 to cancel out the denominators. And that comes as a cross multiplication. So I can just pull out my calculator here. And I can go 4 times 26, which equals 104, and that's 11x. And now to get x by itself, I can just divide by 11. And x, we get 9.45. Ta-da! That was nice. All right, so what happens if I was just spice things up a little bit, as one does? And let's do some of that. And let's say I have 7, and then I have 2x minus 23, and then I have, shoot, let's go 25. Just kidding, pranked. I don't want to do that. And let's do 14 and 22. Okay, well, the way that I can set this up is I'm looking for, remember, my corresponding sides. Well, I know that 7 is the side that has both angles marked. So that means 14 has the side that has both angles marked. So I can say 7 over 14. And now that's going to be 2x minus 23 over 22. And so we need to solve, let's solve for x in this one. There are a few ways that you can do this. You can cross multiply from here and solve that way. I can also look at this ratio and say, well, I know that that has to be 1/2. And so that tells me that to get from 7 to 14, let's do another color. 7 to 14 was a times 2, which means that 2x minus 23 to get to 22 was a times 2. So that tells me that 2x minus 23 has to be 11, because that's what you have to multiply by 2 to get to 11. Or I could have cross multiplied from there. I'm just showing you different ways. 2x equals 34, so I get x as 17.